This podcast is on the concept of formal charge. It's a method that chemists use to decide which Lewis structure is most likely when more than one structure can be drawn. Let's look at an example, and the example is formaldehyde. CH2O is the formula. There are two possibilities that would satisfy the octet rule, which would give you CH and O, an H in a line, or two H's on the C and a bond to the O. An atom's formal charge is the difference between the number of valence electrons in an isolated atom and the number of electrons assigned to that atom in a Lewis structure, and it's calculated. You take the number of valence electrons in the free atom, subtract from it the number of lone pairs or non-bonding electrons, and then half the electrons that are in a bond, and assign all of those to the atom and come up with the formal charge. Now, the sum of the formal charges of the atoms in a molecular ion have to equal the charge on the molecular ion, or you've done something wrong. So here's the first sample of a possible Lewis structure for the formaldehyde molecule. We count them up. There are 12 electrons total. We have two single bonds and a double bond and two lone pairs, so you notice that the Lewis structure is accurate. The formal charge is equal to, well, let's do the carbon first. Carbon always has 4 electrons. There are 2 lone pairs. There are 3 bonds involving 6 electrons. So the formal charge works out to be -1. Now let's do the oxygen. There are 6 electrons on a normal oxygen atom. There's 2 electrons in the 1 lone pair, and we've got 3 bonds, so the formal charge in oxygen is +1. Now let's look at the second structure. Once again, we have 12 electrons. We have 2 singles, a double, and 2 lone pairs for a total of 12 electrons, so the Lewis structure is a plausible one. Formal charge on the carbon is, well, as we said before, carbon has 4 electrons. There are no lone pairs on that carbon, but there are 4 bonds, so a half times 8. We end up with a formal charge of 0 on carbon. And when you do oxygen, oxygen again has 6. There are 4 lone pairs on the oxygen, and there are 2 bonds, 1 double. So the formal charge in oxygen is 0. Now, for neutral molecules, a Lewis structure in which there are no formal charges on any atom is preferable to one in which formal charges are present. Lewis structures with large formal charges are less plausible than those with small. And among Lewis structures having similar distributions of formal charges, the most plausible structure is the one in which negative formal charges are placed on the more electronegative atoms. So which is the most likely Lewis structure for the formaldehyde molecule? Well, which one has no formal charge? And that is indeed the most likely structure for the formaldehyde molecule.